Well, here I've made a sketch, and you should be able to draw any of these sketches. You should practice drawing the sketches until they make sense, because it's these pictures that'll stay with you. Now, formulas that you memorize are not likely to stay with you unless you understand all the parts of the formula, and if you do, you probably understand how they fit into the graph, and hopefully you can just visualize the graph. But you really should be drawing these graphs and making sense of them. Draw it until you can make sense of it. So, same picture we had before. Now I've included something, the fact that delta y is f prime of x naught times delta x. On the tangent line, f prime of x naught is the slope, delta y is the rise is equal to the run multiplied by the slope. Okay, now we want to ask the question, what if the graph of the actual function differs, as it probably will, from the tangent line graph? So here's our, I'm going to draw what might be our function. Okay, there's a function, has some curvature. I think I missed the tangent line. I was looking at it from the wrong angle. Let's pretend it really is tangent there. It looks like a point of tangents is more like here. But this is regarded as a schematic. I screwed it up a little bit, but you could easily draw one yourself. Okay, so here's our x, of course. Okay, and if, yeah, I'm not going to draw that in, never mind. Okay, so here's our value of x. Where's the actual value of y equals f of x? So here's our function. Y equals f of x. For this value of x, the y value is actually here. And if we project that over to the y-axis, which I need to extend just a little bit, yeah, I should have written that y just a little left. Y equals f of x. Now I labeled the value of y that corresponds to this point on our tangent line y sub tan, just to indicate that this is the tangent line approximation, and this is the actual f of x, and the part of that arrow looks a little bit like a prime, so we don't want to confuse this with a derivative. Okay, so here's our value of y equals f of x. Here's our point on the tangent line. So the coordinates of this point here are x, f of x. Okay, that's this point. And the coordinates of this point here are, didn't leave myself a lot of room, but I'm going to write it here, x y naught plus f prime of x naught times x minus x naught. Okay, those will be the coordinates of this point. So that our discrepancy, I'll call it a discrepancy rather than an error, because it's not really an error, because we're doing it intentionally and predictably, but the discrepancy between our predicted value and the actual value of the function is represented here. So I'm going to say discrepancy is what? It's f of x minus y tan, okay? And that's just f of x minus the quantity y naught plus f prime of x naught times x minus x naught. Okay, the value we started with plus the delta y. F prime of x naught delta x. Now instead of delta x, I wrote x minus x naught here. Maybe I ought to make that completely delta x is x minus x naught, but let's go ahead and write it out that way. Okay? There's the discrepancy. Now, y naught, of course, is just f of x naught. So that equals, and I'm going to do a couple of steps of algebra at once here. Okay, y naught is just f of x naught. So I got f of x minus f of x naught. And then I have, and I don't know why yeah, okay, I know why, minus f prime of x naught times x minus x naught. Okay. This is the actual difference in the value of the function. This is the difference as predicted by the tangent line.